Hello student, in last lecture I have explained you chapter first A in 10th physics. Today I will do some numericals from exercise first A. The formula we'll use in this exercise first is for torque or moment of force symbol is torque is equal to force into perpendicular distance. Okay. During calculating torque, you have to mention the type of torque with answer. Okay. After calculating the value of torque, you should mention SI unit and the type of torque, clockwise or anti-clockwise. And second one is principle of movements. What was it? Anti-clockwise movement is equal to clockwise movement. These are the two formulas we'll use in this exercise. So let's come to the question. Numericals, question number first. The moment of force of 10 Newton about a fixed point O is 5 Newton per Newton meter. Calculate the distance of point O from the line of action of the force. Consider this is fixed point. You can call it axis of rotation, and the moment of force of 10 Newton. A force F is applied here, 10 Newton, and the moment of force of this force, moment of force of this force about this point is 5 Newton meter. Calculate the distance of point O from the line of action of force. This is line of action of force, this is fixed point O, or you can call it axis of rotation. We have to find this distance O, let's say it A, OA we have to find. Then the moment of force is equal to force into perpendicular distance between axis of rotation and line of action of force, OA. Then OA is equal to tau over F. The value of tau 5 upon force is 10. 0.5 and unit is meter. Okay. This is a very simple question. Here this is the axis of rotation. This is applied force of 10 Newton. We have to find the distance. We have to find the perpendicular distance between axis of rotation and line of action of force. Okay. Then we will use this formula. Tau is equal to F into this is perpendicular distance. And we will find OA. Write the answer with its SI unit. It's a very important thing. Otherwise your marks will be deducted. You have to mention SI unit with answer. Okay, this is the numerical number first. Now, question number third. A wheel of diameter 2 meter. There is a wheel, center and diameter, let's say it A and B. AB is equal to 2 meter. The diameter of this wheel is 2 meter. With axle at O. This is axle. This is the pivotal point, or you can call it axis of rotation. A force F is equal to 2 Newton is applied at B. And this direction, force F is applied at B. Force is equal to 2 Newton. What is the line of action of force? This is the line of action of force. The line along with the force X. calculate the moment of force. We have to calculate the moment of force about the center O and point A. Moment of force about O. Formula is tau is equal to force into. In first part, we have to calculate the moment of force about O. It means O is the axis of rotation. Point O is the axis of rotation. Then the moment of force about O is given by force into perpendicular distance between force and what is the axis of rotation? In first part, point O. We have to take this distance. F into OB. F is 2 and OB is equal to 1. This is total 2 meter diameter, then this radius is 1. 2 Newton meter. This is the SI unit. Okay. And what will be the type of this moment of force? This force is tries to rotate this wheel in this direction, clockwise direction. You should mention clockwise. Okay. Now in second part, we have to find moment of force about point A. Now point A is the axis of rotation. So the torque about point A is given by force into perpendicular distance between line of action of force and axis of rotation. In second part, now we have to find moment of force about point A. It means point A is the axis of rotation. Then the distance from line of action from axis of rotation is AB, and this is 2 into AB is 2 meter. This is 4 Newton meter. This is also clockwise. If we apply force in this direction, then this force try to rotate this wheel in clockwise direction. So the moment of force about O and about A will be clockwise. This is the question number 3. Now question number 4. The diagram in figure 1.29 shows two forces F1 and F2 acting at a point A and B of a rod pivoted at point O. Consider a rod A and B. It is pivoted at this point. Pivoted at this point. It means this is axis of rotation. A force F1 and F2 acting like this. This is F1. The value of F1 is 5 Newton and this is F2. F2 is 3 Newton. Such that OA is equal to 2 meter and OB is equal to 4 meter. OA 2 meter and OB is equal to 4 meter. So the total distance of this rod is 6 meter. Now we have to find the moment of force F1 about O. Moment of force F1 and about which point? About O. We have to find moment of force of this force about this point. About this point means this is axis of rotation. Then you can say tau 1, moment of force due to force F1. Formula force of which we have to find moment F1 and perpendicular distance between line of action of force and axis of rotation. So the line of action of this force along this line and axis of rotation here, then the perpendicular distance will be this 2 meter or OA. F1 is 5 into OA is 2. This is 2 Newton meter. And what will be the type of this torque? Listen, this force is trying to rotate this rod in this direction. Consider we have a rod like this, and this is axis of rotation. If we apply some force F1 in downward direction, then the rod will rotate in anti-clock direction. Okay? This is anti-clock direction. Anti-clock. As I told you, you have to mention SI unit and the type of torque. Now, in the second part, the moment of force F2. Moment of force F2 about O. Now, it is called torque. Force F2 and perpendicular distance between line of action of this force F2 and axis of rotation is OB. F2 is 3 Newton and OB is 4 meter. Then this is 12 Newton meter. And what will be the type of this force? This force try to rotate this rod is in clockwise direction. This is clockwise. Okay, if we apply, we have to find the tendency of moment of force produced by force F2. Then axis of rotation is here. If we apply some force at this point in downward direction, then this rod will rotate in clockwise direction. Okay, this is clockwise. Now, in third part, it is a very important part. Total moment of force of two forces about O. Okay, now in third part we have to calculate the total moment of force of these two forces. We have calculated the moment of force for every force individually. We have to find. We have calculated individually moment of force produced by these two given forces F1 and F2. In third part, we have to calculate total moment of force. Then total moment of force is the algebraic sum of these two moment of forces. Now listen carefully. These two moment of forces having different types. This is anti-clock and this is clock. Then for finding total moment of force produced by every individual given force, if the tendency are different, then we have to subtract. Okay, we have to subtract 12 minus 10. Answer is 2 Newton meter. And 12 having tendency clockwise, this is the greater moment of force compared to this. So the tendency of total moment of force or resultant moment of force is of tendency of moment of force produced by bigger value. The moment of force which is bigger, having the same tendency of total moment of force, then this is clockwise. Okay, got it? If we want to calculate total moment of force produced by every individual force, then if the individual moment of forces having different tendencies, then we have to subtract to find the total moment of force, and the answer and the tendency of answer will be the tendency of moment of force which has bigger value. And if they are of same tendency, let's suppose this is anti-clock, this is anti-clock, or this is clockwise, this is clockwise, then for calculating total moment of force we have to add these values. Got it? This is a very important part. So for finding total moment of force, if the moment of force produced by individual forces having different tendency, then we have to subtract those values, and the tendency of moment of force is same as the tendency of moment of force having bigger value. This one is bigger, and the tendency of this force is clockwise, then the tendency of moment of force resultant is clockwise. Okay, this is a very important question. Now question number 5. Two forces each of magnitude 10 Newton act vertically upward and downward respectively at two ends A and B of a uniform rod of length 4 meter. Consider we have a rod AB having length 4 meter and two forces each of 10 Newton are applied like this. 10 Newton and this also 10 Newton. This is point O pivoted at its midpoint. This is the midpoint. It means this is 2 meter and this is 2 meter. Determine the magnitude of resultant moment of forces. In this question we have to calculate the total moment of forces about this point. Total moment of force. One method for finding total moment of force is that find the moment of force produced by each force separately and then add both moment of forces. Okay? As like in question 4, third part. And the second method is, as we have seen, that these forces are equal and opposite forces having different line of action, then these make a force couple. So the resultant moment of force is equal to moment of force couple, and moment of force couple is given by force into couple R. Force is 10 and couple R means distance between line of action of these two forces of couple, which is 4 meter. This is 40 Newton meter. This is the resultant moment of force, or you can call it moment of force couple, and we have a direct formula for moment of force couple, then you can apply it. Otherwise, the second method is we have to find the moment of force produced by each separate force and then that algebraic sum to get total moment of force, like in question number 4, third part. And the tendency of this moment of force, this couple, consider we have a rod, and if we apply one force here and this force is here, then the rod will rotate in this direction. It is clockwise direction. So this is clockwise. You have to mention that time. Okay, this is the question number 5. Now, question number 7. A steering wheel of diameter 0.5 meter is rotated anti-clockwise by applying two forces, each of magnitude 5 meter. Consider this is a steering wheel and this is center of wheel, and it is rotated anti-clockwise. Anti-clockwise means in this direction. This is anti-clockwise. And how we rotate steering wheel? We apply force in like this situation. This is the diameter. One force here and one force here, equal and opposite forces. Then if we apply the force like this, then it will rotate in anti-clockwise direction. And the diameter is 0.5 meter. This is center, let's say AB, and forces are of equal amount. 5 Newton. Forces are 5 Newton. Okay. Draw the diagram to show the application of forces. This is the diagram for showing the application of forces. Calculate the moment of forces applied. Moment of forces. We have to find total moment of forces. We don't have to find moment of a single force. We have to find moment of force produced, total moment of force produced by both forces, or you can call it force, moment of force couple. So, moment of forces is equal to force into couple R. We can apply this formula because both forces having same value but in opposite direction. F into AB. F is 5 and AB is 0.5, 2.5 Newton meter, and this is anti-clock given in question. Okay. This is question number. It was the question number 7. This was the question number 7. Now, your homework, for your homework, question number 2, 6, question number 2 and 6 from numerical, and read exercise. In the beginning of exercise first day, there are some short questions, just like question number first, state the condition when applying force the body has. Question number 2, define moment of force in the state SI unit. So, complete this exercise. If you have any problem in any question, you can come. Okay? And these numerical from the numerical section of this exercise, please do it on your notebook. And the exercise first day, in beginning, there are some short questions. Total 27 questions are there. You have to read it only. First, you have to read the theory of this chapter, and after that, you can try to do this short question exercise. If you have any problem, you can come.